Excellent. So let's go ahead and get started. This is me, Michael Minella. I'm the co-lead for Spring Batch. I've been on the Spring team for about 7 years, working on Spring Cloud Task, a whole bunch of other stuff. You don't care about most of that. This is how to get a hold of me. If you have any questions after this, if you do download all this stuff I'll be showing you later, and some of this interests you, these are ways to get a hold of me via Twitter, my personal account, the Spring Batch account, and then I'm on a podcast called Off Heap. And so Off Heap is a podcast that you can check out. It's a bunch of people hanging out, talking about the latest news in the JVM and that kind of thing. So if that's something that interests you, definitely check that out. I also have a book available. If this interests you, there's actually a whole chapter dedicated to expanding on this talk. So specifically on running batch workloads in the cloud. So if you are working with Spring Batch and are interested in what we're going to talk about today, I definitely would appreciate you buying the book. Slides, code, all that. A version of this talk is out on GitHub right now. The rest, what I'm demoing today, will be on shortly after I complete the talk today. I want to thank everybody for coming out and hanging out during this talk. There's a great lineup of amazing speakers, and you have chosen this time right now to listen to the most amazing technology that you're going to hear about all day, batch processing. While batch processing has been around literally since the dawn of time, it is still very relevant. The computing started in the batch world, but it is still very relevant. We're still doing ETL. We're still orchestrating workloads, whether it be CI/CD style orchestration or jobs on Kubernetes, all these different kinds of things. Data science still uses batch workloads for things like model training and those kinds of things. IoT is another case where you see batch processing still being used. And with modern tools and patterns, you can really turn batch into a very powerful tool on the modern cloud. And so what are we going to talk about today? We're going to do two things. First of all, I'm going into this assuming that not everybody is a Spring Batch expert. So I'm going to spend a little bit of time just doing kind of a Spring Batch 101. You're not going to be an expert once you're done with this, but it's enough where when I talk about jobs and steps and chunks and those kinds of things, you'll understand what I'm talking about. Kind of a level set. Then we're going to look at an application, and we're going to iterate on that application. We're going to iterate on it a couple times. And basically, we're going to start off with just my plain batch application, and then we're going to add features that will allow it to behave properly in a cloud-native world. So Spring Batch 101. What is batch processing? Batch processing is defined as the code my boss wrote before I was born, and now I'm stuck with maintaining. No, not really. Batch processing really is, in my view at least, batch processing is defined as the processing of a finite amount of data without interaction or interruption. Those pieces there are really important when you think about when to use batch processing. You hear a lot about streaming and other types of workloads, specifically in the cloud world, but batch is unique in this world in a couple ways. First of all, most workloads you think about, whether they be integration workloads, whether they be REST APIs, etc., the paradigm of how they are deployed is all the same. I take my application, I deploy this onto a server, and then it waits. It waits until it gets some type of external response, right? So if I've got an integration app, it might wait for a message. If I have a REST API, it will wait for a request. All these kinds of things where it waits for some type of external stimulus. Batch processing is different. Batch processing, what it's going to do is you're going to gear up everything in advance, and then you're going to say go. And so that's where it runs on that processing without interaction or interruption. You get everything together, you say go, and it runs. Some lingo in this world. You'll hear me talking about jobs. A job is the entire flow that you're going to execute. So when we talk about the finite process that we're going to run from start to finish, that is the job. A job can consist of many different steps. So a step is a unit of work that will be executed from start to finish before another step is started. We'll get into kind of how the flow of steps within a job works in just a minute. There are two main types of steps within Spring Batch. There's a tasklet step and a chunk-based step. Tasklet step is essentially you implement an interface called tasklet. It has a single method on it called execute. And whatever you stick in that method, we're going to run within the scope of a transaction for you. It's kind of the roll your own step, if you will. The chunk-based step is really where you get into processing individual items. So here, let's say I've got a file with 1 million records that I need to process. You're probably going to use a chunk-based step where you're going to read from the file, pass it potentially to a processor, and write out to the to something else. Within a chunk-based step, there's an important piece that you need to figure out, which is what is your item? What is that thing that you're going to loop over in the scope of a chunk-based step? This is about as much art as there is science into deciding what this is. You know, let's say we've got a bank and we're processing bank transactions. Is the item the transaction itself? Is it the account? Is it, which may have multiple transactions? Is it the customer who may have multiple accounts, which may have multiple transactions? You need to determine what makes sense to loop over based on the design of your step. When we put these all together, all these items together into a chunk, that's really a transaction. So if we take, going back to I've got a file that's got 1 million records, or I've got a database table that's got 1 million records in it that I need to process. I'm probably not going to want to process all of those records in a single transaction. I'm going to want to break those up into multiple transactions. And if things fail, I'm going to want to restart at a chunk that was the last good place that I left off. This is where chunk processing within Spring Batch allows you to do. So it allows you to say, I've got that 1 million record database table. Every 1,000 items, I want to do those within a transaction. I'll process those 1,000 records, commit my transaction, update where I'm at, and then do the next 1,000. And that process loops over and over until you've processed all 1 million. The advantages of this is it allows you to keep state of where you're at as you process, so that you can do things like if you get halfway through your table and it fails, you can start back up without having to process that first 500,000 records that you've already done. When we think about a Spring Batch job, it looks something like this. This would be 3 steps, each one of them being chunk-based. Step 1 would start, process, and finish. Step 2 would start, then step 2 would start, process, and finish. And then step 3 would start, process, and finish. Within a chunk-based step, there are 3 main components. There's an item reader, an optional item processor, and an item writer. The item reader is responsible for providing the data. So it's going to read from somewhere. It's going to read from a database table or a file, or insert other option here. Your item processor is where most of your business logic is going to live. This is where you're doing essentially the transformation or modification of whatever you've read in. Both the item reader and the item processor are item-based. We'll get to how these all interact in just a minute. The item writer is responsible for the output of the step. So the reader brings the data in, the processor modifies it, the writer persists it out. Within a chunk-oriented step, the flow of how data goes through that step looks something like this. So I've got a step. It's going to call the read method on the item reader for each item that the item reader returns. So let's say I've configured, going back to that previous example, let's say I've configured my chunk size to be 1,000 records. It's going to call the read method on the item reader 1,000 times, building up a list of 1,000 items. Then it's going to iterate over that list one at a time, passing each one to the item processor and taking those results and persisting those in memory as well. Once all of the items within my chunk have been read and processed, I then take the entire list and pass that to the item writer. The reason we do that is item reader and processor being item-based and item writer being chunk-based, essentially, is because that allows certain optimizations in the item writer that you can't really get within the item reader and processor and still do fault tolerance. Things like batch inserts if you're writing to a database, or flushing an entire chunk to disk for if you're writing a file, doing that all at once, things like that. Batch processors are essentially stateful processes. let me rephrase that. The batch applications are essentially stateful applications. The process itself is not stateful because we externalize the state. The way we do that is via the job repository. So the job repository is a relational database that keeps track of what has happened during your job execution. So the way a job runs is you have a job launcher. The job launcher is going to report to the job repository, I'm starting job A. The job is going to report to the job repository, I'm starting step A, I'm starting step B, I'm starting step C. The step is going to report to the job repository, I've finished chunk 1, I've finished chunk 5, I've finished chunk 10. So that if the job fails, it can be restarted and all of the metadata you need to restart your application is stored in that job repository. So now you're all Spring Batch experts. Let's talk about actually working on a Spring Batch application. And so we're going to iterate on an application. My goal with this app is I didn't want to spend a lot of time digging into a domain out that was really complex. So forgive me if the batch job itself feels mind-numbingly simple. The goal here is not to spend a ton of time digging into Spring Batch features here. It's to dig into the cloud native application of features on top of the Spring Batch application. So we've got an application. I've got some files sitting out in Amazon S3, just because it's a convenient place to drop some files. We're going to do an import process. So this job is going to read from S3, download those files, and it's going to import them into a database. Real complicated stuff. The way this job is going to be structured is it is a single step job. So I've got one job with a single step called load. And that step has 3 main components. It's got a flat file item reader. Each one of these files is a CSV with 3 columns. I've got an enrichment item processor. This item processor is going to call out to a REST service for us. That REST service is literally just going to return how many times it's been called. So enriched 1, enriched 2, enriched 3, and so forth. The enriched item processor will apply that to my domain object and pass that on to the JDBC batch item writer, who will actually persist that information to the MySQL database. Everything hopefully is pretty simple here. Let's go ahead and dive into some code so we can understand how these pieces all fit together and kind of understand where we're going to go from there. Let's go ahead and go to IntelliJ. So I've got a 3-module project. I've got the batch job, a domain module that just has my domain object, and a REST service. The REST service, I'll start off here because this is probably the most familiar to everybody. This is Spring Boot basics. This should be pretty straightforward to anybody who's comfortable with Spring Boot. This is the traditional main method class that everybody does a Spring Boot app for. And I've got a simple controller. It's a REST controller, get mapping /enrich. It keeps a static count and returns just like I said, enriched and then the count. Nothing complex here. On the batch job, let's take a look at what's going on over here. So I've got a couple things here. I've got, again, my main method here. I've got enable batch processing. So what this does is this enables, if you will, the Spring Batch infrastructure to be bootstrapped by Spring Boot. So things like setting up the job repository, setting up a job launcher, and those kinds of things. The infrastructure that you need to run a batch job, a Spring Batch job within Spring Boot, enable batch processing does that for you. We can ignore all of this. That applies for a later version of this. And then the rest is pretty much what you'd expect. I've got 2 custom components I've written for this batch job. The first one is this downloading job execution listener. This is what's actually going to download the files from S3 to my job. And so the way this works is when I run my job, before the job actually runs, this listener will kick in, and I'm using the AWS resource to actually download the files. The other piece to this, the custom piece, is that enrichment item processor. So here I've got a REST template. I'm going to make a simple call to the first iteration will run locally, then we'll move to the cloud. So I'm just going to call localhost 8080 /enrich and just slap whatever I get back into my message field of my domain object. If we go to the domain object itself, You can see, like I said, it's really complicated. First, second, third, those three fields come from the CSV file we're going to be reading in, and message is what we'll be adding afterwards. So those are all the custom components for my batch job. Let's take a look at the actual configuration of the batch job. So here I have configuration. I've got two builders here, the step builder factory and the job builder factory. These are builders that are going to let me build a batch job and step with Spring Batch. You'll notice I've configured that downloading job execution listener here. And then I'm going to go from the bottom up, actually. So I've got a REST template. That's for the listener, or I'm sorry, that's for the item processor that we looked at a minute ago. I've got my job. So I've got this.jobbuilderfactory.get, the name of the job. I'm defining my listener so that this will do the download for us. Start indicates what step to start at. And then finally build is going to build my job. If we look at load, which is my step, so here I've got a stepbuilderfactory.get, the name is load. My chunk size is 20, so I will read in 20 items at a time. I provide my three different components, the reader, the processor, and the writer, and then I call build. Moving up the chain, so I've got my writer. Actually, I've got all three here. So my reader is this flat file item reader. Actually, we'll get to the reader in a minute. Go up from bottom up. So on the writer side, I've got the JDBC batch item writer. So this is going to write in each chunk in one insert the records to the database. So I provided a data source. I say it's bean mapped, so I can say just do first, second, third, and message here. And then Spring Batch will call get first, get second, get third, and get message to populate these fields. It's SQL. That's the SQL insert that I'm going to use, and then call build. I've got the item processor here. Again, nothing to configure there. And then lastly, I've got two pieces for the reader. The first one is this flat file item reader. This is what's actually going to read my input in. So I go flat file item reader builder. I provided a name. So this is a piece we used for the state persistence. These are delimited files. It's a CSV, so I call delimited. I give an array of names for each column. So column 1 in the CSV is called first, column 2 is second, column 3 is third, and identify that my target type is foo. So by doing that, it's going to call set first, set second, and set third as it reads this file. And I call build and return it. Now I'm reading more than one file. There's actually 2 files I'll be processing with this. So I've actually got an additional reader. This is the multi-resource item reader. This wraps the flat file item reader. And what it's going to do is it's going to look at the resources I provide to it. So in this case, I'm going to give it a list of file names. And for each one of those files it finds, it's going to delegate to the flat file item reader to actually do the reading. I know there's probably a lot going on there. Hopefully it wasn't too complex. Let's go ahead and build it and run it. Make sure I'm in the right spot. Yep. Quick build. Cool. And so now I can do, let's do it this way. So first I'll start the REST service. So that's started. And then I will go ahead and run my job. And before I hit enter, I will bounce over to here and just show drop, create. So nothing up my sleeves. This isn't pre-populated. This really is live. So I hope this works. So go ahead and run my batch job. Excellent. So the important pieces we see here is that the job was completed with following parameters, don't care, but it was completed. That means that we were successful. You can see some of the system.outs I put in there earlier on. So this is where like the downloaded files actually ended up, all that kind of stuff. But the important thing here is if we now do that, we can see the data got into the database. So now that we have our application, let's go ahead and take a look at some additional stuff. I know you're like me and you write perfect code and you never have problems in production or really anywhere with any of the code you write. But we also know that we get data and other things from other people, and when they give you bad data and when they cause problems to your systems, your application needs to be able to handle it. And so one of the ways that you can handle errors in the cloud in a cloud-friendly way is a circuit breaker. You've probably heard about circuit breakers before. The idea here is when something goes wrong, if it's going to keep going wrong, you probably don't want to keep doing it. You know, Einstein said sign of insanity is doing the same thing over and over and expecting the same result or expecting a different result. And so a circuit breaker kind of addresses that. So if you have an error that is intermittent, let's say you've got a flaky REST service, which we're about to have. Let's say you've got network issues, those kinds of things. You can have a circuit breaker that will essentially try to do your normal logic. If it succeeds, great, it continues on. If it fails, it flips the breaker and calls something else, basically to fill in, if you will, for those errors. And then the advantage of the circuit breaker is it doesn't beat up the original logic. It will wait a certain period of time or a certain number of tries or whatever metric you choose to allow that other service to recover. So let's go ahead and take a look. The nice thing about what Spring Batch has is there's an implementation of circuit breaker that actually comes with Spring Batch. Most people didn't realize this. The Spring Batch uses the framework Spring Retry internally, and Spring Retry has its own implementation of a circuit breaker. And so that's what we're going to use in our application. So let me go ahead and check out what I need. Okay, so now we should be good there. And now let's go ahead and take a look. So this version has two key changes. The first is in the REST service. Obviously, in order for this demo to work, I need a flaky REST service. So I'm going to have a random amount of times this service is going to throw an exception, or just runtime exception saying I screwed up. Now, on the flip side of that, the piece that's calling this REST service needs to implement that circuit breaker. And so here, there's a little bit of new code here in this enrichment processor. Actually, sorry, there's one additional thing, which is enable retry. So you need that annotation as well. No additional dependencies, I should note, no additional dependencies are required for this piece. Everything you need is with Spring Batch out of the box. So this is my method that I want to have the circuit breaker wrap around it. It's a process method. No changes are here. So I wrap that with a circuit breaker annotation. That tells me that that's the method that I want to try, and if there's failures, flip the breaker. The other piece of this is this recover method. And so when my circuit breaker method throws an exception, the recover method is where the circuit breaker is going to defer to while the other one recovers. And so in this case, it's just going to say the word error. So when I run this, ideally what should happen, or the way we know the circuit breaker is working, is that when we look at the logs for the REST service, we'll see those exceptions being thrown. We should see less exceptions thrown or equal as we do the word error in that message field. If we see the same number or more, something went wrong. The idea being that the circuit breaker is going to flip, and it's just going to put error in there a few times without calling the REST service to allow it to recover. So let's go ahead and do a quick build. While we're doing that, I'll go ahead and, I already did it, but just to back to normal. So there's that, and then go ahead and launch my REST service again. Cool, REST service started. And let's go ahead and run our job. All right, it's all done. Let's go ahead and take a look at the results. So you can see I've got an error in every record. Okay, how many times was our service actually called? That's the key here. And so if we go through, we can see it was called once, it was called twice, called 3 times. The service itself was only called 3 times. Each time it happened to throw an error, but I was able to get something for each one of my results. Now it's important to realize that I forgot where I was going with that. In Spring Batch, if you are an experienced Spring Batch user, you may be scratching your head and be like, why not just use Spring Batch's retry mechanism? That's already there too. The difference between these two mechanisms is a Spring Batch retry mechanism that actually is built into Spring Batch itself actually rolls back the transaction, changes the commit size to 1, and then tries them individually to identify the individual record. There's a performance hit for that. So if you have, let's say, a flaky REST API that you're going to call like this, there's the risk that you're going to have a large overhead for rolling back, reprocessing all those items for no real reason. So this can be a much more performant option for you. The last iteration we're going to do today is around configuration. So everybody's probably heard of the 12-factor app and the 12-factor manifesto, or 15-factor app, or whatever factors you want. But one of the clear factors there is separating code and configuration. You want them separate so that you can deploy these same artifact anywhere, anytime, no questions, right? There are multiple approaches to handle this. And it's important when we're thinking specifically about Kubernetes, and I've done this talk before with Cloud Foundry, and you can find that on YouTube. But today we're going to talk about Kubernetes, and it's important to think about Kubernetes like a dependency injection container. So think of it like Spring. If you're running an application on Kubernetes, if you need something from the platform, if you need configuration from the platform, if you need service discovery from the platform, it probably can be handed to you as opposed to you calling out to get it. And the examples we're going to look at here is specifically around configuration. So there's a couple different options for configuration. The first one is config maps and secrets. So here you register essentially a chunk of YAML that creates a resource on Kubernetes that is a config map, so it's a configuration file, if you will, or a secrets, which is the secure way of handling usernames, passwords, those kinds of things on the Kubernetes platform. That's for basic configuration stuff, right? That's for databases and URLs and that kind of stuff, and Spring Boot properties and that kind of stuff, right? There's also service discovery, and Kubernetes out of the box gives you DNS, and so that's actually a really powerful thing. If you're going to run, let's say, a REST service like what I'm doing, you can just point to the DNS and not have to worry about true service discovery anymore, because DNS does that for you. And so when we look at our application, what we're going to do is we're going to use config maps and secrets to configure our batch job. And we're going to use DNS to find out where the REST service actually is. Up to now, I've been running localhost. This next round, we're going to actually run on Minikube locally. Let's go ahead and take a look. So I'm out of this. I don't need my local MySQL anymore. I can kill that. I already have Minikube running. This is actually MySQL now on Minikube. You can see the kubectl if the picture is good enough. And again, we'll just go ahead and drop and recreate, so there's nothing there. Go ahead and kill off this. So now I'm on my Kubernetes. I've got nothing running right now. The only thing I've got running right now is MySQL. So if I do a quick kubectl get pods, so you see the only thing I've got running right now is MySQL. So let's go ahead and do a couple things. First, we are going to, where is my, here. So let's go ahead and look at some of the configurations we're going to be doing. So first of all, we're going to create a config map of the properties I need. And here's the properties I'm using. So I'm deploying this this part isn't really used. The data source, so I'm configuring my data source. You'll notice here that I don't have a username or password here. The one thing I do already have set up on Kubernetes is my secrets. And so I've got in my README, when I push this up to GitHub, I've got a version of that you'll be able to see, the command I use to create. Like I said, I've got a command in my README that will address that. So, but all the secrets, all the sensitive stuff is out of my application.yaml. We're actually going to create a config map out of this application.yaml. So this is the data source. I've got my batch stuff. It's going to initialize the database for me since I just blew it away. This is where I'm getting my files from on S3. We don't have to worry about that. And then this is the region in Amazon, and specifically I'm telling Amazon don't do the auto detect functionality that Spring Cloud AWS enables. So let's go ahead and create our config map. README. And all I need to do this is this. So kubectl create config map, the name of my config map, and then I'm just saying from file in that file. So what this is going to do is this is going to create a file, a config map for me. Now the cool thing about config maps and secrets is there are a number of ways of pushing those into your container. Like I said, think Spring DI. Kubernetes is going to give it to you instead of you asking for it. And so in this case, I'm actually going to mount this config map onto a disk in my container. So as far as my application is concerned, it's going to get an application.yaml just like I would any other application. The secrets will be injected via environment variables to handle that aspect as well. So now I've got my config map all set up. I've already built my Docker images, so I don't have to build those. There are directions, as you can see in here, on how to create those as well when I push this up to GitHub. But now, so to run my REST service, let's go ahead and take a look at the YAML I'm going to push for here. So there's two pieces here. First of all, there's a service, and the service piece gives me that DNS functionality. So I'm basically defining that this is going to be the name of my entry, REST service, and I'm going to expose port 8080 as a service. This next piece is the deployment. So this is what's going to actually set up my pod on Kubernetes, as well as my replica set and all the things that Kubernetes needs to keep my app up and running. So I'm defining the Kubernetes, the Docker image I'm going to run, the container port I'm going to expose, all that kind of stuff. Replicas, so I only want one instance, all that kind of stuff. So let me go ahead and apply that. Actually, one other thing, let's take a look at, where's it at? What else was I going to show? I forgot what I was supposed to show that. So let me go ahead and run this. So we can see we've got the REST service running. Get pods. You can see it's actually running there, and just logs. You can see the REST service has started. Next step is we've already created the config map. Oops. So you can see we've already created the config map. So we don't need to do that anymore. This is the command for creating the secrets. Like I said, you can take a look at that later. I know some people are probably freaking out. These are not real things, or if they are, it's certainly aren't mine. And then we want to actually go ahead and run our job. So let's go ahead and do this. So what's going to happen right now? This is going to run my job, or it's going to create a pod, and Kubernetes is going to mount onto that pod a drive that is going to show. Let me go ahead and grab this. So batch job, that really doesn't matter. The image, always pull it, and then I've got all my environment variables. So Spring config location. So this is where to look for that application.yaml that Kubernetes is going to mount. So I'm telling it to go ahead and mount down here. This is me telling, between these two, this is me telling Kubernetes to mount my application.yaml at deployments.config. Then I set an environment variable that says, look for application.yamls in this deployments.config. So that tells Spring Boot where to look. The rest of the stuff is pretty boilerplate. So I've got Spring Data Source URL. Again, I'm using DNS because MySQL has a service as well that I'm running. So MySQL, that's all I need to provide. Username, passwords, username of hard-coded, password is passed in via secrets. Same with these other, the AWS credentials are all passed in via secrets. That was the other thing I was going to show. In the enrichment processor, you can see I'm using instead of using localhost or an IP here, I'm using REST service :8080. So REST service gives me the DNS resolution to find where that REST service is. So let's go ahead and run my job. So we can take a look. Pods, you can see it's running. Go ahead and bounce over to where we at here. And you can see it ran, the circuit breaker kicked in, and everything, and also as well as it was able to successfully talk to the REST service. So I realized that was kind of a pretty lightning round version of, what does a batch process look like on Kubernetes? But hopefully you realize that when you go cloud native with Spring applications, whether they be boot by themselves or batch processing, they can really allow you to take your batch processes specifically and deploy them to the cloud with minimal trouble. And with that, I've been told we're going to do some live Q&A.
My gosh, I think you're right, Michael. I appreciate you showing me the COBOL images. I went back in time. All right, so folks, the reason we have not been answering your questions is we're going to do it live. So I'm going to go with the easy one first. Michael, can I configure multiple jobs in a single app?
Excellent question. You can. However, I wouldn't recommend it. And the reason I wouldn't recommend it is going back to the whole cloud native thing. Having lots of small artifacts is probably a better option than having them do than having one big one. We talk about how Josh Long, who's concluding this conference, likes to talk a lot about how production is his favorite place on the internet, right? And the easiest way to get an application from your laptop to production is to make it the smallest amount of code possible. And so when you put a bunch of different jobs in the same jar file and couple them together like that, think of the process you need to go through to get from laptop to production. A lot of places, specifically when we're dealing with batch workloads, there may be, dev, QA, change control, all kinds of other bureaucratic processes that you need to get through. And it's been my experience that the smaller the code change and the smaller ball of stuff you're trying to get through that process, the more efficient it is to make that happen. And so that's the main reason I recommend decoupling those as much as you can, because if I only have a small change to one batch job, I don't need to prove that this other batch job wasn't touched if it's packaged that way.
Well, cool. The next question is, is this similar to Apache Camel as far as Spring Batch? And when we have multiple instances, how may we make them? How do we do? Okay, here's a question. Let me go ahead and clean it up. Is this similar to Apache Camel? What if I have multiple jobs? How do we make sure they don't compete with each other?
Excellent question. So is it similar to Apache Camel? Apache Camel is actually closer to Spring Integration than Spring Batch. Apache Camel actually, I believe, let me just triple check.
It's an implementation of enterprise integration patterns.
Well, the thing so there's actually a Spring Batch component for Apache Camel, which was what I was double checking on. And basically it allows you to launch Spring Batch applications via messages. So the closer analogy between Camel and a Spring product would be Camel to Spring Integration. That was that piece. I forgot. I apologize. I forgot what the other half was.
How do we make, okay, in his, I'm going to try to word it to where it's clear here. Again, thank you for the question. It's a good question. And when we have multiple instances, multiple jobs, how do we make sure that they don't compete with each other? So if I've got like 5, 10, 20, 2,000 jobs, how do they not compete?
So, like all interesting questions, the answer is it depends. I apologize. I need a little more detail on what you mean by compete. Are you talking about competing for resources, or are you talking about competing for, like, I'm going to launch 2 instances of the same job and I want to make sure only one finish, is it actually does the work? There's a lot of different things related to that. So that being said, what I can say is Spring Batch does not orchestrate. That's probably something that's important to call out. Spring Batch runs batch workloads, but they don't. It's still on you to orchestrate how these jobs are managed. So whether you run one after the other, whether you run 50 in parallel, do you run them on a schedule? Do you run them ad hoc? All these kinds of orchestration questions, Spring Batch does not handle. We do have something else called Spring Cloud Data Flow, which unfortunately, due to the time constraints of this conference, I had to cut that piece out. But data flow is where you start to answer those questions. So data flow has things like the compose task runner that will run jobs in sequence or in parallel or those kinds of things. It has things like setting limits on how many will run in parallel on a platform. All those kinds of orchestrational concerns, I'm going to send you to data flow, and that's really where you want to be looking.
Sweet. That is an excellent answer there. Thank you. Again, thank you for these questions. Keep them coming. Okay, this one actually says directly to you, Michael. So, Michael, how do I run the batch job in a clustered environment and make only one instant take the lead and completes the job?
Okay, so excellent question. So the way that works is actually it should happen automatically if you've got your database configured in a friendly way. The serialization aspect of that across those is actually handled by the database. So Spring Batch will not allow you to launch 2 job instances at the same time, or at all, really. And so Spring Batch should handle that just out of the box. Now, when I say what do I mean by a job instance, right? So I didn't get into the data model of the job repository. I talked about the job repository, but I didn't get into the data model of it. So there's 2 key pieces at the job level. There's a job instance and a job execution. The job instance is a logical run. So let's say you've got a job that runs every day. A job instance would be the Monday run, the Tuesday run, the Wednesday run, and so forth. The physical run is going to be a job execution. So a job instance can have multiple job executions. So let's say I run Monday and I run it once and it runs successfully. Great. Tuesday, same thing. Wednesday, we're having a bad day. It gets halfway through and fails. When I restart the job, I'll get another job execution for that same job instance that will pick up where it left off. So I'll have 1 job instance and 2 job executions. So going back to the question of how do I prevent, in a clustered environment, how do I prevent multiple jobs from running at the same time? Spring Batch identifies what a job instance is by the parameters you pass in. And so if you try and start 2 jobs pointing at the same job repository with the same parameters, Spring Batch will not let them both fly.
Awesome. So this next question, it's a can of worms question. It's a good one. And again, folks, thanks for asking them. Okay, I always wonder about job repositories function in relation to a 12-factor app. Should multiple Spring Cloud Batch jobs share the job repository data store, and would that make the job repository a service in itself?
Pull out soapbox, stand up.
All right, I'm standing up for you, Michael. There we go.
So I'm already standing. So excellent question. I get a lot of debate on this, and I argue no. It is not. So you should be able to share that instance across multiple Spring Batch applications. The reason I say that is, basically, when you're talking about externalizing state within the 12-factor world, the key there is one of the driving reasons for that is you don't want your database to become the API that shares data across different services, right? That's one of the key reasons they say to avoid that. That isn't what the Spring Batch database is doing. It is there to maintain state, just for that process. And as long as they're all using similar versions of the framework, I mean, unless you're going literally the last change in the job repository we had was 2.1, I think, when we added non-identifying job parameters. So you'd have to be really disparate in your versions. The job repository is essentially a static thing, and it's a dependency of the framework, not of your business logic or your application. So I argue that it's perfectly safe within the world of 12-factor apps and that kind of thing.
Cool. Sorry. So, do we need to use quartz for batch triggering? And that's a depends question. It depends.
Yeah, exactly. Let me back up. Do you want to use quartz? Because really that's what it comes down to, is going back to the orchestration thing. Spring Batch doesn't do orchestration. One of the reasons we don't is it's been my experience that schedulers and those orchestration tools are a very religious topic at most enterprises. Thou shalt not touch my scheduler kind of situations. And so our goal is just to integrate with whatever you have. So if you're using Control M, we'll work with Control M. If you want to use data flow and use the platform scheduler, you can use the platform scheduler. In this case, going back to, we're just running on Kubernetes, you could use, Kubernetes has the concept of cron jobs built in. So if you're looking to use cron and you're already on Kubernetes, you already have that functionality built in. If you had nothing and you're running on bare metal, yeah, using Quartz or even the Spring scheduler are perfectly viable options.
Awesome. So here we go. Does Spring Batch now have some high-level management and monitoring tool?
We do support Micrometer. So Micrometer is a library that, think of it as SLF4J, but for metrics. So Spring Batch provides a set of metrics, and they are exposed via Micrometer. That's actually what Spring Boot 2's metrics is built on as well. And so that piece of it is handled that way, and then whatever backend you choose to plug into it, whether it's Prometheus, whether it's Wavefront or Tanzu observability, or whatever backend you want to plug into it, that's completely up to you, and Spring Batch would support it.
Cool. Okay, I'm out of questions, but Michael, is there anything coming up new in Spring Batch or Task that you would like to chat about, or we're just waiting for September, Spring 1?
Yeah, I mean, the main focus for Batch right now is, kind of following along with the bigger themes that the Spring team has this year, which is, growing the community, playing nice with microservices, playing nice in Kubernetes, all those kinds of things. And so, those are all things that we're looking at and working through. I think the next, the 4.3 release is actually going to be a pretty heavy tech debt cleanup release, to be transparent. It's probably going to be more of that than blockbuster features. But yeah, it's basically what we're working on. And when you've got a framework that's 10, 11 years old, it kind of, we need to take some of those times to do that kind of cleanup.
Well, awesome. Okay, I give everybody one more chance at asking a question. Uh-oh, I did it this time. Okay, we'll get one more question in, and then we'll call it, okay? Let's see. Okay. Well, I'm going to read this comment. It's a comment, Michael. Are you ready?
Mm-hmm.
Spring Batch was used at my previous one of my previous projects to import patient data at the UK National Health Services data warehouse. System is used to research into health issues like pandemics. So you already helped. So there we go.
I really appreciate that comment. I'd love to learn more if whoever made that comment would like to reach out. I'd love to learn more, and thanks for the comment.